Hey everybody, I hope you're doing well. In this video, I want to talk about a question that we didn't get to start during class. This is a velocity question, specifically average velocity, and we will end with an instantaneous velocity at the end. To start us off, we have a car that has a position function given by 0.001 times t squared, where s is measured in miles and t is in minutes. I have several questions that I want to answer here. The first one involves the average velocity of the car in the first hour. So to start off, let's talk a little bit about average velocity. So average velocity really is the change in position divided by the change in time. So specifically for this problem, I will have a change in position, which will be the difference of two positions, divided by the change in time. Now let me give some ideas or some notation. I have an end time and a beginning time, and an end time minus beginning time. Make sure that these letters match up, and then you'll always be in good shape. So for this one, the first hour, that means the end time is 60 minutes and the beginning time is 0. So we're going to calculate for the average time s of 60 minus s of 0 over 60 minus 0. Well, let's see. I'm going to look at 60 squared, which is 3,600, times 0.001, which I believe is 3.6. We're going to subtract 0, and we're going to divide this by 60. So what do we wind up getting? We get 3.6 over 60, or when we're done, I believe 0.6. Now that doesn't seem like an average velocity, but remember this is in miles per minute. So this is mile per minute. That's actually a decent speed. This is an average velocity over the first hour. Now what I'd like to do, instead of writing this down all the time, I want to start using Mathematica a little bit here. So to use Mathematica, let's see if I have this right. I want to clear my two variables and then enter in the function that I'm dealing with. So I already have this. I already evaluated the cell. You'll notice that this S is not blue. Instead of going outside of this cell, I'm going to continue in this one cell, so if I make any errors, I don't have lots of different things to evaluate. So the first thing I need is I need to get a fraction. Well, there's many ways to get a fraction. You can look up in the palettes in the Basic Math Assistant and grab a fraction. I want to compute s of 60 minus s of 0, and I'm going to divide that by 60 minus 0. Let me evaluate this, and I wind up getting, oh, I made a mistake. It's 0.06. I'm glad I did this in Mathematica here. So this calculation right here is 0.06. So that's a very easy thing, or very useful thing that Mathematica can do for us, is that it can show us some of our little mental calculation mistakes. So I'm glad I did this in Mathematica at this moment. So what about the other questions? Well, the other questions, what were they? Average velocity in the first 30 minutes, between 20 and 30 minutes. So let's see if I can actually do this. So how do I do this in the first 30 minutes? Well, this was the first 60 minutes. Let's see, first 30 minutes would be something like this. So that's all I need to do to get my first 30-minute problem in there. So when I'm looking at this, I have my computations for first 60. This one is first 30. Let me bring this back up here. How about between 20 and 30? How is that going to look? Well, let's see. My end time is 30. My beginning time is 20. My end time, I just said, was 30, and my beginning time is 20. So this is between 30 and 20. I'll make this just a little bit wider so it fits in there. Now let me evaluate all of this at once. Now what happens, I wind up getting 3 different numbers. And they all come from these different pieces. So let's try to write this down over here. So the first 30 minutes, we want the ending time of 30, beginning time of 0. And this is equal to, looking at my Mathematica, 0.03 miles per minute. I'm not saying this car is going very, very fast. What about between, what was the next one? Between 20 and 30 minutes. Well, according to Mathematica, again, S of 30 minus S of 20 all over 30 minus 20, and this was equal to 0.05. I'll put a 0 in there so it's easier to see on what's going on. So I believe that answers some of my questions, but I don't think it answers all of them. It says, what about between 29 and 30? Well, that's pretty easy to figure out here, because instead of doing 30 and 20, I do 30 and 29. And I know 30 minus 29 is 1, but I'll just put this in here for now. Now, what's going to happen in Mathematica, we're going to wind up getting so many outputs, and I want to be really, really careful about this. So one thing I can do is, if I put semicolons at the end, I can actually suppress. It's called suppress the output. And so now I'm only getting 0.059 between 30 and 29. So I'll come back to my written stuff. So between 29 and 30, I'm not going to write it all down. I'm going to pick at 059. Now, one thing I can do a little bit better than this. I can look at, well, what about instead of 30 to 29, I try to make this time interval even smaller, 39 and 29.9. So now I'm only going 1/10 of a second here. And that's going to look like 0.0599. So I think, looking at this, I think the limit, well, usually we write limits just with an LIM. As t approaches 30 of this expression, and now notice that I'm putting a t in there instead of a time, and let t get very close. I think this is going to be 0.06 in there. Now it turns out that what we got for the average velocity for the 60 minutes is the instantaneous velocity at 30. That was just coincidence. So I hope this video helps. If you have any questions, just let me know. Have a great day.